it's linear, that means it's only going to go up in a straight line. Okay, that's what linear means. It's a straight line. And this time it's going to go up or down. Growth means up. Decay means down, of course. In this question, by 2, it's going to go up. So you can see it starts off at 20. It's a constant increase of 2 units, a constant increase. So it's not going, 2, then 3, then 4, and then 1 or something like that. It's constantly going up by the same amount. That's what we mean by this one here. In this part here, we're starting at 20 as well, but this time we're going down. That's the decay part. We're going down by 2 all the time. And again, you can see that it's a constant decline. It's not zagged or doesn't start, and then come there and then come like that. It's the same thing all the time. So be aware of that. Right, so if we've got growth, linear growth, it's going to be adding to the previous term. If we've got linear decay, it's going to be subtracting to that previous term. So here we go. We're going to be talking about interest, loans and investments, and we're only talking about simple, so it's going up and down by the same amount. That's what simple means, the same amount. Right, last year you might have seen it, that the interest rate was equal to PRT over 100. That's what simple interest means. Okay, for those of that, if you saw it last year, I can't remember. We're going to be doing the same thing. Now, when I teach you guys this, I'm going to teach you, I'm going to show you the rules, but I'm going to teach you without using rules. Okay, so I want you to think about what I'm saying and how I'm coming about it. It will basically relate back to the rules, but I'm going to get you to find them out, work them out. So just remember that the amount that you borrow or invest is called the principal here. Okay, and we're always adding an amount to it, and it's usually written as a percentage, but in the question it's written as a decimal. Okay, so when we write the recurrence relation, we must write it as a decimal. Okay, there's all your rules for simple interest. I'm going to do it, as I said, without using those rules in a sense. So example 1. Cheryl invests $5,000 in an investment account. Okay, $5,000 is her original. That is her P. Okay, in this case, because we're doing a recurrence relation, it's going to be V of 0, 5,000, the original amount that she invests. So in here, we're writing $5,000. Any questions there? Okay. That pays 4.8% per annum simple interest. Model this simple investment using a recurrence relation. Okay, so we need to get what this D is. Now, because it's a simple interest, it means it's going up by the same every time. That's what that means, every time. That's why it's plus the D, okay, because it's going up by the same amount every time. So let's work out what this amount is. Well, we're getting 4.8% interest. So 4.8%, okay, of, well, we invest $5,000. 4.8% divided by 100 of times $5,000. Okay, so I'm just going to get the calculator out and work that out. So once I do that, and you guys can do it as well on your calculator page, 4.8 divided by 100 times $5,000, you'll get 240. So the next term will go up by $240. That's what our D is. So here, when I write my recurrence relation, I'm going to write V of 0 equals 5,000. You must always have a V of 0 written down. If not, you will not get the marks. Then you're going to write V of n plus 1 will equal V of n plus 240. And we just found our recurrence relation for this example. Any questions there? Okay, I'll give you a bit of time to just write that down. All right. Example 2. Says use the recurrence relation to analyze a simple interest investment. Okay, well here's Cheryl's simple investment. That's when we got the same answer up the top. V of 0 is 5,000 and V of n plus 1 equals V of n plus 240. That's what we just got. Okay, part A. Use the model to determine the value of Cheryl's investment after 3 years. Okay, well, we're going to use the model. We're going to do it straight on our calculator. So put in the original amount of $5,000 and press enter on your calculator. The steps, there's the steps on that you'll see in your calculator, so you don't need to write those. And of course, the $5,000 will go on the side exactly up to there. And then, because this is our rule, get the answer. There it is, get that answer. And plus 240. We're going to press plus 240. The calculator will put the answer in there for us, plus 240, and we're going to press enter. And the next thing we're going to see is 5,240, exactly there. Keep pressing enter. They want to know what's the value of the investment after 3 years. So you have to press enter 3 times because this is our starting value. This is 1 year. This answer here will be 2 years. This answer here will be the 3rd year. So 1, 2, 3. After 3 years, 3 years, the value is $5,720. Any questions there for part A? Okay, part B says, when will Cheryl's investment first exceed $6,000 and what will its value be then? Well, we can keep pressing enter on our calculator as well, but they're already here. That's for 5 years. So after 5 years, it exceeds $6,000. So I'm going to write the answer to part B over here. After 5 years, it exceeds $6,000 and it is $6,200. Any questions there? Okay, I'm going to move on if no one's got a question. Okay. Now that was the increase. Let's do depreciation. Okay, now depreciation, as you know, it means it's going to decrease. Okay, it's going to go down. You have a car, you know, you buy it for, let's say, $10,000, you drive it out, and already it's worth less than $10,000. Even if you reverse it back in and say, I want to sell you my car, then so I'll give you, $8,000 for it. Okay, everything loses value over time. That's what depreciation is. Okay, is go depreciate over time. But we can work out what it will be in 5, 10, whatever years it is. Okay, there will be a point then it's not really worth that much. It's the minimal it's worth. That's what the scrap value is, the minimal that it's worth at that time. Okay. At the end of the time, it's basically going to be written off. Okay. So there's 2 things that we can do here. We can do a flat rate depreciation. What does a flat rate depreciation means? It means it goes down, because depreciation goes down. It means it goes down the same amount every time. Let's say $20 goes down $20 every time. we can do a unit cost depreciation. Okay, unit cost. Let's say we've got your car. Okay, you're all going to be turning 18. Some of you probably are, and some of you are driving. Every kilometre we do on the car, it goes down. Let's say 20 cents. You do 10 kilometres, it's gone down 20 times 10, 200 cents or $2. Okay, that's what unit cost is. It goes down depending on how much you've used it for that unit, whether it's a car, a photocopier. Okay, every time you print a piece of paper, let's say it goes down 3 cents. You print out 10 sheets of paper, it's gone down 30 cents. Unit cost depreciation, okay? And how do we do these? We do it using linear decay on our recurrence relation. So let's do one. Again, here's some rules for flat rate depreciation. Remember, flat rate goes down same amount, goes down same amount every, that's what that means. Example 3, modelling flat rate depreciation. Okay, new car, there we go. New car was purchased for $24,000 in 2014. That's how much we bought it for. That's our initial value, V of 0, 24,000. There we go. It's going to go down. Car depreciates by 20% of its purchase price each year. So each year, it's going down this much on the original purchase price. So let's work out how much it's going down. So it depreciates 20% of $24,000 because that's how much we bought it for. So 20 divided by 100 times 24,000. I'll cross off the 2 zeros. We're looking at 24 times 2 is 48 and 2 zeros. So $4,800 every time. That's how much it's depreciating by. Any questions there? Okay, so each year it's going down by this amount. So now we're going to write our recurrence relation. So V, I've already got my V of 0, there it is. V of n plus 1 will equal V of n minus $4,800. So here, this is where I used here. But remember, I'm making you think, but that's what we're using, that rule. So I've just worked out my recurrence relation. Any questions on example 3? Okay, example 4. I'm hoping this is recorded. I thought I'd press record, but anyway. Example 4. Using a recurrence relation to analyse flat rate depreciation. Okay, so flat rate depreciation of the car is modelled by, okay, that's what we wrote. That's what we found. V of 0 is 24,000. V of n plus 1 equals V of n minus 4,800. Where Vn, value of the car after n years. Okay. Part A, use the model to determine the value of the car after 2 years. So here I'm going to do all the working out for you this time. Okay, just so you can see it in case they want you to do it on the exam. So part A, we've already got V of 0, we're going to do V of 1, which means that to get V of 1, n has to be equal to 0 all the time for these ones here because we've got the n plus 1 and the n. So that means we're going to go V of 0 plus 1 is 1 minus 4,800, which means we have 24,000. That's what, oops, V of 0 is minus 4,800, and we're going to work that out. So we're going to get 19,000, 4,000, yes, 19,200. Now we're going to do the next one. So V of 2, because it wants it after 2 years, that's only after 1 year. So V of 2 equals V of 1 minus 4,800. V of 1 we worked out 19,200. 19,200 minus 4,800. Just going to get out that on our calculator and we're going to work it out again. And that gives us $14,400. So after 2 years, the car is worth $14,400. Any questions on part A? Okay, part B. I'm going to do this on our calculator. If you've already stored it, you're fine, you can continue. But if not, put in 24,000 on your calculator and press enter. So it gets stored. And then go minus 4,800, because that's the rule, minus 4,800, and press enter. And you would get the 19,200. Press enter again, and you'll get the $14,400. And keep pressing enter and counting how many times. Okay, so I'm going to do it on mine, and you can do it. So I've got 24,000, enter, minus 4,800. Okay, 1, 2, 3, 4, 5 years gives me 0. So after 5 years, so in 5 years, the car is worth $0. Any questions on that one? Okay. Right, let's move on to unit cost depreciation. Okay, as I said, it's based on how much time you're using it, or kilometres you're putting in on the car, or paper that you're printing on a photocopier or a printer or whatever. So it's a unit. It's costing you so much every time. Again, there's the rules. I'm just going to go through them with you so you can understand it. Not the rules. I'm going to make you think of how we understand how we get this. So example 5. Professional gardener purchased a lawnmower for $270. Well, there's my V of 0. Mower depreciates in value by $3.50 each time it's used. Model the depreciating value of this mower using a recurrence relation of the form. There it is there. Well, we know that it goes down $3.50 every time. So I've got my V of 0, there it is there. So my V of n plus 1 will equal my V of n minus $3.50. There's my recurrence relation. Any questions there? Okay. If we look at example 6, that is the same question with the recurrence relation already there. Okay, it says use part A, use the model to determine the value of the mower after it's been used 3 times. Okay, so let's do that. Again, I'll show you all the steps here, and then part B, we're just going to do it on the calc. So part A, 3 times. Okay, so V of 1 will equal V of 0 minus the $3.50. So V of 1 is going to be 270 minus $3.50. Okay, we can all work that out. We get V of 1 equals to $266.50. Okay, let's do V of 2. The second time, $266.50, and we're going to take away another $3.50. So once we do that, we end up getting $263. So now it's worth $263. They won after 3 times. That's only the second use. Okay, so the third use, V of 3, is going to be V of 2 minus $3.50. B of 2, $263 minus $3.50. So take away the $3.50, what do we get? We get $259, oops, let me get rid of that, $259.50. So after 3 times, it is worth $259.50. Any questions on that one? Okay. Part B, how many times can the mower be used before it depreciates? Depreciated value is less than 250. Okay, so we're going to do this on the calculator. We're going to start off with the original, 270. We're going to press enter so it gets stored, and then we're going to go take away $3.50 and press enter, and it'll give us the 266.50. Keep pressing enter and count. So we've got 1 already. That's the 266.50. 2 gives us $263. 3 times gives us the 259. Keep counting. 4, 5, 6 times. So 6 times. How many times? 6 times before less than $250. How much is it? It is worth $249 if you've done it. Okay, $249 now. That's the first time we've got underneath 250. Any questions there? Okay. All right, that is the end of 8C. So I'm going to keep you still online for a little bit. Keep doing questions. I'll just stop this sharing in about 10 seconds so that you can copy down anything that you need to, and I'll have you all online so I can see you. And then about 10 minutes or so, if you haven't got any questions, I'll let you go.